Right, I've got a weird heating system, and the problem I've got with it at the minute is my old controller is broke, and I need to make a new controller to transfer heat from this pump to the other tank. At the minute, this is my current controller, which is manual settings, and it is a pain to do at this time of year, so we're going to make a new one. Okay, so this is the plan. There's an Arduino now, which is reading the temperatures of two sensors. One will be in each tank, and the difference of those two will define whether this relay is on or off, which will turn the pump that transfers hot water from the small tank into the big tank. And then there's this screen which will give us an indication of how hot each of the tanks are, and just so that we can check to make sure that the system is working correctly. I'm not going to bore you with anything else of this, so we're going to go straight over to soldering. Right, so we're following this, and we've got to put in all the different pins. So this is going to mount to this. So to get the connectors in, it's best to put them all in, and then to help make sure they all line up on the board is to put them in the board even though they're not necessarily connected to it. So the next bit, we need a signal wire to go from D2 to this connection terminal here. Okay, so we've done the signal wires and the earth grounds on these and a positive. This is a, what do they call it? A pull-up resistor. So it's taking power from the main power route and putting it into the signal rail so that it makes the signal more stable, I believe. And so we're just going to jump across from the power to the signal cable on the other side of the board. Okay, so I think I can wheel the resistor in between this slot, so it's on top, and it makes all the soldering on the back, which makes everything a lot neater. So that end goes in there, that end goes in there, and then Right, so I've had a change of plan, because I am making it up as I go along anyway. And originally, I was going to have this mounted in a box this way up, and then screen going over here. But actually, for ease of wiring, if I do it this way up, the controller for the screen fits in quite nicely here. And so when we take the lid of the box off to do anything to it, we can just do this with the wires, and that makes wiring this end a lot easier. So we're going to do it that way. And once we've got this wired in, we'll then design the box. So we've got our little unit, got power, sensors, AC power, got to go in, and the screen tell us what's going on. Okay, so this is MakerBox.io, and I want to make a box. So we're going to have a width of 100 internal. We're going to have a height of 55 internal and a depth of 40, because it just gives us all a little bit more room for having more bits in. The material we're using is 3.8 millimeters, and we're going to download a PDF of that. Tab width is 20. It's quite chunky, but it's less cutting for the printer. It doesn't need to be that finer print. So let's knock this out into Inkscape. So this is our box that we're going to put the thing in. I've taken the PDF and made the stroke all red so that it's a cutout command on the printer, and I've added a cutout for the screen and for the cables to go in and out. These are the main cables, this is the power cable, USB thing, and this is the signal cables for the thermometers. The reason the USB's got a black box around it is that the ply is too thick and the connection on the Arduino Nano isn't long enough to stick all the way through the ply, so just by doing a raster engrave on the box, it will allow a thin section of ply to be around the hole, and it will allow us to plug in the power a lot easier. So let's get this cut out. Go! Reason didn't cut through is the plywood had filler in it. And the laser cutter doesn't seem to be able to cut the filler in this plywood. But never mind. What's in the box? Right, so I've just got to build up the glue in the box a little bit just so that I can get the ports on the circuit board at the right height so that they line up with the holes I made in the box. Right, so after much faffing, got it working, got temperatures on the probes. This one here is the small tank, and when it reaches 5 degrees above the large tank probe, it will simulate by putting it in a warm place. In theory, the light should come on. Maybe. It doesn't. Oh yeah. Helps if you plug it in all the way. Cool. So if we pull this down, I need a cold thing. I don't have a cold thing. If we warm this one up to it, God, it's going to taste awful. The relay should kick in here. And turn this off. There we go. Nice. Right. It works. Now I'll go and install it downstairs.
Right, so in theory, in 0.2 of a degree, oh there we go, 0.2 of a degree, this pump down here, this little green one, should turn on. But in the meantime, until it does that, I will show you what I've done. So this is plugged into the mains up here, and the relay in the box will turn on when the top number is 5 degrees more than the bottom number, and then the power that it's turning on will come down here, which is plugged into this pump here, and this pump transfers the heat that's in the small tank on the left, can't see it because it's insulated, into the big tank on the right. And that way it means we have warmer showers, but it means our thermal store is building temperature. And 35 degrees at this time of year is not too bad. The solar's starting to kick in now, so hopefully this is going to go up soonish. And then this is thermometer for the big tank, and then the other wire runs down and into the box, into here, and there's a little thermometer slot in the side of the tank for it. So now all we need to do is wait for this to go up. It's nearly there. It flashed up for a second and then it's dropped back down again. Or 5 seconds, because that's the interval it's testing at. Up again. Is that enough? Does it have to be over? I think it has to be over. So we might have to wait for the next iteration. There we go. So that should click now. And then that means that that pump there has come on. See how the little green lights have come on it? And then that will turn until it makes that temperature there go down, because it's pumping warm water in and taking cold water out. There we go, struggling with that light a bit. Ooh, come on camera. There we go. Is it going to have an instantaneous effect or is it going to take a minute? Right, so if you like interesting little projects like this, I'm going to try and explain my heating system in a lot more detail soon, if you're interested. It's not a standard system by any means. It works on solar and wood-burning stove, both of which I installed myself. And then it uses this thermal heat store, which is just starting to come back into effect now that winter's mostly over. So I will give you a little tour on that, and if you're interested you need to subscribe to the channel so that YouTube may or may not actually notify you that I release a video about it. But anyway, if not, I will see you next week.